So today's one is actually not what is prior use justification. It's functional safety management for engineering companies. And as usual, some of you are probably very familiar with the exida webinars and what we do, and some of you maybe not. When I look through the names, I see some new names, which is good. And so welcome to our weekly webinars that we run. And just to tell you a little bit about exida, we actually have been in business now for 20 years. It was our official 20th anniversary, supposed to be in March of this year, but unfortunately, due to what happened with COVID, we had to cancel our arrangements and couldn't have people flying in, unfortunately. And since then, of course, we've all been working in very interesting, different times from what any of us have experienced before. But hopefully we'll all be able to get through it, and business seems to be continuing as usual. So just a little bit about exida's background. As I said, it was formed 20 years ago, just over, by two of the leading lights in safety at the time. And they formed the company really to try and start off initially helping manufacturers understand what this new standard 1508 was all about, the IEC 61508 as it is now. And since then, the company's grown tremendously. We just moved from doing the certification for products from the safety point of view to being able to do people certification, as well as providing lifecycle service support for the three main life cycles involved with process safety, which of course is alarm management, cybersecurity, and functional safety. In conjunction, we've also developed the capability of doing product certification from a cybersecurity point of view, so we're doing more of that now. And in parallel, we've developed a suite of tools to help support not just manufacturers, but also the end users. And we've grown globally as well. So we're now all around the globe, and we operate in different industries. These industries vary from place to place, of course, but primarily anywhere that needs functional safety, cybersecurity, or alarm management. And more recently, in the last decade, has been more on the automotive side, and even still more recently has been robotics. There's a lot of autonomous robots now being used in warehouses, and you've probably seen these large black towers in some of the supermarkets. At least here in the US, they've had them wandering around doing cleaning. So all of that needs to be taken care of, especially if it's a large industrial cleaning machine, because they can weigh 300 or 400 pounds, and you don't want them crushing people. A little bit about me. I've been in industry now for 43 years and started life as an electronics engineer doing hardware and software design for control systems, and then moved into safety in the early 80s, developing some of the ESD and fire and gas modules and systems with ICS in the UK, and addressable fire systems as well. Then I spent nearly 17 years with an automation supplier. And about 8 years ago, I came back into safety with exida. And one of my roles is to be an instructor for the functional safety course. And some of you I see attending have been on these courses with me. So you're probably familiar, remember me. And also I look after the end user business. So how we measure our success is we've moved away from being just originally two owners to being more, more employee owned. And now we have well over 100 global experts, as well as having done over 1,000 certification assessment projects and modeled 500,000 or more with our Excellencia tool. Certification, as I mentioned, now we do the CFSE, the CFSP for the people, the Certified Functional Safety Expert and Professional. And from the cyber side, there's the Controls Automation Cybersecurity Expert and the Controls Automation Cybersecurity Specialist. So those are two of the certifications we do for cybersecurity. and then for the product certification, of course, the functional safety and the cybersecurity. We are now a leader in logic solver certification as well, which is another area we've moved into, and of course reference materials. So we do provide a lot of information through the website, and whenever I teach my classes, I always encourage people to use the resources through the Exida website because there's a lot of good information and it's mostly free. The books you see here you can purchase through the website, and the SERH is the Safety Equipment Reliability Handbook, and this is all the failure rate data that's built into the Excellencia tool. There's also white papers and webinars that are recorded that you can access through the website, as well as the Safe Automation Equipment List, the Safety Automation Equipment List, which gives you a list of certified devices. So if you're looking for devices to use in a safety instrumented system design, then I encourage you to utilize the SAEL in our website because it's free. Excellencia, we have a suite where we can either have these tools as being modules, so the PHA tool, the LOPA tool, those are standalone, or they can be part of the suite. Once the data's in the tools, then it's available to any of the other modules in the tool suite, and you can do the PHA separately if you wish, or it can be part of the suite. We can import and export to and from the tool, so we can bring in PHA Pro or PHA Works files into the PHA tool, and then that can move into the LOPA tool once we've finished doing PHA and we've identified LOPA candidates. And then from the LOPA tool, we can go into the Select tool for the targeting and then generate the initial SRS, do the SIF design in the Silver tool, as well as the SIL verification. And this is where all the failure rates come in, and then create the design SRS and the proof tests. The SIL alarm tool helps us to create a master alarm database. So if we've identified any alarms through PHA and LOPA that we want to take credit for and use as a layer of protection, then we can pull those into the SIL alarm tool and start developing the master alarm database. And the SILstat tool is used with the field for gathering data. So you can export all the SIF information for each of the SIFs into the SILstat tool, including the proof tests, and then using a tablet, you can run the proof tests in the field, you can record all the information, and you can also record demands, whether they're real or otherwise, near misses, failures, etc. All of that can be stored in the tool and then used later on for analysis. And as it said, we do that because of the way we've structured the database, and so we can basically feed information to any of the tools once it's inside Excellencia. And we can export to enterprise management systems as well as asset management systems. So that's basically a brief introduction. So let's get to the meat of this, which is functional safety management systems and the specifics for engineering company and integrator requirements. So one of the reasons why I've put this webinar together is, again, conversations that I've had over the last, I don't know, probably a year or so with many engineering and integrator companies concerning this, because it's a requirement that's now been put into 1511 and has been in there since the changes in 2016, so basically 4 years. And engineering companies and integrators should start to be doing this if they're going to be compliant with 1511. So let's look at the reasons why. Well, this is the famous HSE study that was done in 95 and then done again in 2003, where they looked at the causes of accidents involving control systems and safety systems. And what they found was 44% was due to bad specification, 15% due to design and implementation. So of course, if your spec's bad, your design's not going to be much better. And effectively, all of these come down to being systematic failures. And so what's happened is, in the interim years, the number of accidents or the number of incidents hasn't really decreased to the extent that we would expect it to decrease if people were following what's known as RAGAGAP, recognized and generally accepted good engineering practice. And so when the standard was changed in 2016, more emphasis was put on functional safety management and having a functional safety management system in place and a plan in place, and not just for the end users, but for also anyone who's claiming to offer any service or product for any part of the life cycle also has to prove that they have a functional safety management system in place. And this is all because we should be following best practice. Now, those of you that have been on the courses and are very familiar with functional safety know that it's all built around a life cycle. There are three phases. There's an analysis phase, there's a design and implementation phase, and there's an operation and maintenance phase. And that these three phases are very important to make sure that we are designing a safety instrumented system correctly. In the analysis phase, of course, we're looking at identifying what are the hazards that we're trying to protect against from causing major serious consequences. And usually when we talk about consequences, we're talking about harm, we're talking about fatality, we're talking about potential environmental problems, and also financial for equipment and damage to the plant. So the idea was to have a balanced approach to help us balance our design and our risk to achieve optimum performance and cost. And in order to do that, there are a number of things that we have to do. Now, of course, all of this is highly dependent upon the culture of the organization. If the culture of the organization is supportive and wanting to create the environment that is safer, then obviously this is much easier to be able to follow and achieve. If the culture is one of financial, in other words, minimum cost, maximum operating profit, then it's very difficult to sometimes convince management that this is necessary. These things that we have to do are necessary in order to be able to, in the longer run, have a much more efficient and actually lower cost operation than if we don't do this. We cut corners, we take on more risk, we're going to end up with higher cost at the end of the day. And I can't tell you how many conversations I've had with management teams where a lot of this gets challenged. So of course the objectives are, again, we want to avoid the systematic faults. And again, those that have been on the course will know that I talk about the 3 Ps. I characterize the 3 Ps when it comes to systematic. And the 3 Ps are personnel. Are they properly trained and competent to do the work that we're asking them to do? And this is another area where the standard has tightened up on competency requirements. And then the second one is to do with procedures. Do we have written procedures that are being followed? And in a lot of cases where accidents have occurred, it's usually some violation of the procedures. Then the third P, of course, is the paperwork. Do we have a paper trail that proves that we're doing what we said we were going to do and that we can follow? The second thing is to reduce the potential for random faults. And random faults obviously is down to primarily the way the hardware is designed and the reliability of the hardware. And I say primarily because people can make random mistakes. You can be well trained, you can have a good procedure that's correct, but you're just having a bad day and you make a mistake. So when it comes to the life cycle, there's what I like to call the glue that holds it all together, and that's functional safety management. And this is very important. So again, if we're not following through correctly, if we're not doing the right things, then we could introduce potential systematic issues. So this is very important. And as I said, this is dependent upon the culture of the business. If the business is focused on trying to do the right things and is willing to invest the time and the money to make sure things are done correctly, then this is much easier to be able to achieve. If not, then it becomes more difficult. And I'm sure some of you listening have probably been in that boat. Now, when it comes to the requirements for engineering contractors and integrators, this is where the rubber meets the road, as it is. And these are some of the questions that I have been asked, believe it or not, by engineering companies or system integrators. What legal obligation do I have to include and follow a functional safety management system? Well, the simple answer to that is there is no legal requirement. However, if you come under OSHA PSM requirements, you are expected to follow RAGAGAP, as I said in the earlier slide. The same in the UK with COMA. RAGAGAP being recognized and generally accepted good engineering practice. And IEC 61511 is recognized as being RAGAGAPs, one of the RAGAGAPs. So the point is, if you don't follow a functional safety management system, then you are increasing your risk, because the purpose of functional safety management systems are to help us to manage those 3 Ps, to help us reduce as far as possible the potential for systematic errors. And if we don't do that, and we have a problem that's due to a systematic error, then of course it can be financially crippling, depending on how bad the accident is. And from the point of view of if the engineering company hasn't done the right things, then the engineering company could be exposed. And the other question is, why do I need to consider having functional safety management system and a functional safety management plan in place? Well, again, the whole point is that if the engineering company has responsibility for designing a safety instrumented system, then they have to make sure that they're following the correct requirements of 1511. And the plan is very important to show how we're going to implement functional safety when it comes to designing the safety instrumented system. The other question is, who's going to pay for this? And of course the answer is, well, you know, pay me now or pay me later. If you have a real problem, if there is an incident, there is an explosion, there are fatalities, then of course litigation. And we've only got to point to the BP Deepwater Horizon example. And right now, the latest estimates for that, the cost of that accident to BP is around, their own estimates is around $62 billion. So if you don't do this, then you're going to be running much greater risk. What's my return on investment if I follow this? Well, if you actually follow this and do it right, it'll help in the long term, because the system will be operating to its optimum. And I know that once the engineering company hands it over to the end user, it's the end user's responsibility then to make sure that it is maintained. What's the benefit to my company? Well, the benefit to the company, of course, is that if you have your processes and procedures assessed to 61511 and certified to that, then you obviously are ahead of the game. So basically, the answers to all of these is that 1511 under clause 5252 says, if a supplier makes any functional safety claims for a product or service which are used by the organization to demonstrate compliance with the requirements of this part of 1511, the supplier shall have a functional safety management system. The word there is shall, which means you have to have it. Procedures shall be in place to demonstrate the adequacy of the functional safety management system, and the functional safety management system shall meet the requirements of the basic safety standard IEC 61508 2010 clause 6. or the functional safety management requirements of the standard derived from 1508 to which functional safety claims are made. So here again, if your client requires an IEC 615 compliant safety instrumented system, then how are you going to demonstrate you meet this requirement if you don't have a functional safety management system in place and a functional safety management plan that is being followed, and you don't have the audit evidence to prove it? Now, the other thing to remember, of course, is if you as a supplier then choose to use sub-suppliers involved in the SIS, then your sub-suppliers also have to meet this. So this is not a trivial thing. So what does it mean in reality? Well, if you're a system integrator or an engineering company supplying safety instrumented systems, equipment on all systems to demonstrate that they're following the functional safety management system and have a functional safety management plan in place. So this need to demonstrate is very important. The other thing is that there have to be procedures in place. Now, the good news is that most engineering companies, if they've got some form of ISO 9000 quality system, will have probably most of the elements they need to create a functional safety management system and to create a functional safety management plan. And the thing is that most of them that I talk to and have been involved with, when you look at them, the procedures, there are quite a few of them have procedures that could meet some of the requirements, but they're just not called functional safety management or under a functional safety management umbrella. So the whole purpose of all of this is to provide the evidence that we've taken the appropriate steps to help reduce the possibility of introducing systematic failures. Now remember that HSE study showed that 44% was due to bad specification. So therefore, if we're following a functional safety management system correctly and we've gone through and we have all the correct documentation, and one of the other questions that I get asked as well is that where engineering companies say to me, well, we didn't do the analysis. We haven't done the HAZOP, we haven't done the LOPA, we're relying on that to be provided correctly. We're just taking the SRS and we're designing to the SRS. Well, here again, yes, you're designing to the SRS, but there should be some form of functional safety assessment done on the SRS to make sure that the SRS is complete to that point before the detailed design is done. And this is a gray area because, of course, the interfaces where you're going from one company to another company can be blurred. Those interface lines can be blurred as where responsibility begins and ends. This is another reason why 1511 was modified to include roles and responsibilities. So roles and responsibilities have to be clearly defined. And therefore, even though the engineering company is working to the SRS, it behooves them to make sure that they have what they need to be able to do this. Functional safety audits should be carried out to document and provide evidence that the functional safety management system is being implemented correctly. And here again, you can do internal audits with using people not involved in the design, or you can use a third party to come in and do the audit. There's no, obviously with the third party, there's complete independence. And then proof of competency and competency development. This is another area where the standard has tightened up on the competency requirements. So here again, as part of your functional safety management system, you would have some form of competency tracking, either a competency matrix or some form of training document that shows that people are properly trained to be able to work on these particular phases of the life cycle and these particular tasks of the life cycle. So this is another one. And then roles and responsibilities, as I said. So this is what it means. Another question I get asked is, how do I get started? Well, the simple thing is that, as I said already, most engineering companies and integrators will have some form of quality system, managed quality system in place, either to an ISO requirement, in which case this is the foundation to build from. So you don't reinvent the wheel. That's the whole point. So what we do is we would come in and do a simple gap analysis. It's a relatively short time frame, doesn't take too long, usually 2-3 days depending, and then it's relatively low cost. And what you get from that is you can get a report with recommendations. And right now we're doing these remotely, so you can conduct it remotely as long as the documentation is there to be reviewed. So it gives an idea, it gives an indication of where the gaps are. And then the recommendations would be made on how to close those gaps. And one approach that has been very successful with a number of clients is a roadmap. So the roadmap approach basically says, okay, here are these gaps. And then we sit with the client and say, okay, how do you want to prioritize these? And so what we can do is we can look at the priorities, we can look at the resource availability from the client side, and then we can create a roadmap, which is basically a timetable for how these gaps would be filled and the work required to fill them. And then it can be mapped out over a time frame that is comfortable to the client and the engineering company, and also to budget. Because, I mean, these days budgets are always very tight, so it could be mapped out over 12 months, it could be mapped out over 18 months. And then the point is that you can do the budgeting based upon the priorities, and you can create a roadmap, which is basically a plan of how to implement it. So it gives visibility to management. Moreover, if you are audited, you've got evidence to show that you are following a plan. And you can identify the key milestones, etc. So it's not that difficult to get started. And as I've said already, it's not reinventing the wheel. So developing the functional safety management system, you need to first and foremost identify the procedures that need to be in place. And then obviously from the gap, we would identify what needs to be in place. You can use templates. We actually have a whole series of templates designed for this purpose. And then you can develop a plan for implementation. So the whole thing is you approach this like you would any project. So there's a project approach. You can nominate a project manager, and you can create the plan, identify the tasks, of course, the time scale, implement. You could do the audits, reviews, and obviously improve. So it's the usual cycle, the usual project cycle. Also creating metrics. So you would want to create a set of metrics for performance measurement to see how you're doing against what you've laid out. And you could use a form of leading and lagging indicators. In other words, if there are mistakes that have been made in the past, are you able to reduce those mistakes? If there are iterations in some of the design process, can we reduce that? What can we do? So you can look at these things, and then you can set up functional safety assessments and audit reviews. So from the point of view of the designing the SIS, if you're the integrator or the engineering company doing the phase 2 work, which is basically design and implementation, then at the end of the phase 2 work, we would want to do a functional safety 2, just to make sure that we've covered everything correctly up to that point. And again, that could be done by an qualified independent third party, or by using other resources within the company that are competent and qualified to do the work. And that way you've got evidence that things are either working correctly, or if the audits find non-conformances or non-compliances, then they would have to be resolved within a given period of time. And then we would have to re-audit again to make sure it was done. Similarly to where any quality system would work. So here again, it's not that difficult to do this. Creating the right environment is very important. I mentioned this earlier, that if we have the right culture, then what we want to do is develop an open and learning environment to support our functional safety management system implementation. So in other words, what we want to do is encourage staff to be more open and to identify areas that they see as needing improvement. So if some things aren't working well, if some of the procedures are a little bit cumbersome to work with, then they shouldn't be afraid to speak up and say, look, we really need to look at this. It also keeps everyone more actively involved, which is important because they feel that they have a stake in what's going on, which of course they would do, because that's the whole point. And then we would want to develop some form of feedback system to help us with our performance improvements. So this is the benefits of having a more open and learning environment. But as I said, that really comes down to the culture. If the culture's there to support and encourage this, then it'll work. If it's not, it's going to be very difficult. Which is why management support is so vital for a successful implementation of functional safety management. The operational benefits that will be realized if we make fewer mistakes or create fewer errors as a result of having or not having incomplete and or undocumented processes, then that's much better. Because here again, osmosis doesn't work that well when you're relying on people to know what they're supposed to be doing if you don't define what that needs is, for example. It's also easier to find omissions and errors earlier in the life cycle. So this saves cost, of course, because the further down the life cycle you go, the more expensive it becomes to fix problems. And here again, from the design and implementation phase, the engineering company would need to make sure that when it gets the SRS, the first thing to do is to make sure that the SRS is as complete as it can be up to that point. Because if there's missing information, or if the SRS has ambiguity in it, or things that are not clearly defined, because for each CIF there has to be a functional requirement and an integrity requirement, and we also need to define what the timing requirements are. So there's, again, 1511 defines what's required in the SRS. So if the engineering company isn't responsible for generating the SRS, when they're given the SRS, their responsibility is to make sure it's as complete as it can be before they start. So any omissions or errors could be spotted quickly, and that's why it's a good idea to be involved in a functional safety assessment. Now, at the end of the analysis phase, when we have the initial SRS, there should be a functional safety 1 assessment conducted to make sure that the hazard and risk assessment was done properly, that the LOPA was done, and that the CIFs have been properly identified, and they have the right targets set for their SIL levels. So all of these things. And then, of course, making sure that the people are trained and competent. This will also help with improving effectiveness and efficiency, of course. So these are some of the benefits of doing this. And again, I'm sure some of you are saying, well, this is obvious, but it's not always obvious, unfortunately. So having a plan in place provides visibility to the regulator as well, because if you do get visited, then you can show that there's a plan in place. Even if your end user wants to audit you, then you've also can show that. It provides us with the ability to demonstrate compliance, which is the other thing, and that's very important. If we're conducting regular functional safety audits, then that can help also provide the evidence that we're actually following the functional safety management system and doing what we said we were going to do. And of course, with this open and learning environment, gives us the ability to improve. So it's all about continuous improvement as well, and it's not just a once and done. as with any of these. So in summary then, the majority of accidents have been traced back to systematic issues. That's a given. You can just go back. In fact, funnily enough, yesterday I was looking at the CSP website to see what new videos and what new reports they had. And again, you can go through and you see there's still accidents occurring where we're still getting these problems. OSHA and COMA require manufacturers of hazardous materials and processes to follow RAGAGAP. That's also a given, recognized and generally accepted good engineering practice or industry best practices. 1511 requires suppliers of equipment and systems to have a functional safety management system in place. So there's no excuse now, we have to have that in place. And engineering companies and system integrators need to demonstrate compliance. Otherwise, if your client says, I need you to give me a SIS that's 61511 compliant, how are you going to prove that you've done that? Yeah, you may design the SIS to 1511, but if you haven't got a functional safety management system in place and you're not following it or you can't demonstrate it, then that's going to be a problem. Because we have to make sure that we are managing the possibility or managing systematic issues and trying to reduce them to as low a level as possible. And this is done through the use of functional safety management, functional safety assessments, and audits, plus also making sure that our people are competent and that we have development plans to ensure their competency. Roles and responsibilities also need to be clearly defined. So this is very important as well. It's no good having an organization chart with people's names on there if the people don't know what they're supposed to be responsible for. And moreover, if they're not competent to do that. So these are things that have to be done. You can start by doing a simple gap, which is relatively low cost. It'll identify where the gaps are, and then you can develop a roadmap to bridge any of these gaps, and you can budget it according to what the company's timing and requirements are. Prioritizing helps with dealing with those tasks that need to be picked up first, and looking at what resources are required and the availability of those resources to be able to work on it. And right now we're working with several clients at the moment doing just that. It also provides visibility to regulators or auditors, and a clear path can be defined moving forward. It helps us, of course, with being able to plan efficiently. That's the other thing that's required. So there are benefits to be gained from it, not just costs. And if you just look at the costs without looking at the benefits, and the trouble is, unfortunately, in my conversations, it's clear that the companies were just focusing on the short term. And that can be pretty dangerous if you're not thinking about what's going to happen longer term, if you're looking at just cutting costs to start with. And that does not mean to say we shouldn't be budget conscious. Of course we should, but we need to do it in a balanced way. Just cutting costs for the sake of cutting costs and saying, oh, no, we can't afford to do that. We can't do it on this project. There's no budget for it on this project. You have to look at it as not just being specifically for the project, but if you're an engineering company that's regularly doing this, then you need to, it behooves you to have this in place and to be able to demonstrate that you have a proper functional safety management system in place, and you do functional safety management planning, and you can prove it. And one way of doing that is that you can, if you choose, you can go for 1511 certification of your processes and procedures to show compliance. That's one way of doing it. Or you can start off with, as I said, a simple gap assessment and then looking at how to fill the gaps to create the functional safety management system and the functional safety management plan. And we've been doing this recently for some clients, and it's a good way to go. So that's it in a nutshell. As always, you can follow us, and if there are any questions, let's see, I can see my little question mark thingy here. How can you expect that an EPC or integrator can really verify if the SRS is relevant if they have no process background or process that is protected? Well, again, this is where you can use a third party to review the SRS, or you can ask to be in on the functional safety assessment that's done for the SRS. I mean, the whole point is that if the EPC is taking responsibility for using the SRS, then they have to make sure that the SRS is correct. And again, competency. We have to have people that are able to do this, or we have to be able to utilize resources, whether it's a third party or it's another part of the company where we have that expertise. Is it possible to get the recording of this webinar? Yes, the webinar is recorded and put on the website, so you can access it through the website. Is there a difference between a functional safety assessment and a functional safety audit? Yes, there is a specific difference. The assessment has certain criteria that needs to be followed depending on what type of assessment it is. The audit is looking at the documentation to make sure that if we said we were going to do a design review, there is evidence that we conducted a design review and that the people attending the design review were the right people and they were competent to do so. I know sometimes people do interchange those two terms, but they are significantly different when it comes to what it means and what we do. Do exida have a book or white paper on FSM? Yes, the book is coming out shortly. It's undergoing final review at the moment. It's taken a bit longer because of course, COVID. But that's functional safety for managers, what managers need to know, and that covers FSM. There's also a white paper on our website on FSM. There's also previous webinars I've done on FSM that you can pick up. Can you give a specific example of an assessment? Well, a functional safety assessment 1, for example, what we do there is we look at how was the HAZOP done. Did the HAZOP cover all of the required hazards? What were the consequence outcomes? How were they ranked severity-wise? Were they LOPA'd? Was the LOPA done correctly? To make sure that we have what we need at the end of the analysis phase. So the SRS has captured all the hazards correctly. We've identified the need for safety instrumented functions. We've identified what those SIL targets need to be for those safety instrumented functions. And here again, depending on how you've done the targeting, if you've done it qualitatively, then you have to make sure that you've got enough risk reduction. Because if you merely say SIL 2, then you actually mean a SIL 2 with a risk reduction factor of greater than 500. If you just say SIL 2, the designer can give you a SIL 2 with a risk reduction factor of 101, and he's met SIL 2, but he's not met the target. So you need to be very specific in that case. In case of the system integrator FSM covering only phase 4, what's phase 4? So we can declare compliance on this phase only. There are only 3 phases. There's the analysis phase, there's design and implementation, and there's operation and maintenance. There's only 3 phases. So if you're referring to, I'm not sure what you're referring to, phase 4. Again, the point is at the end of the phase 2, the design phase, we should do an FSA2, which can be done as part of the factory acceptance test to make sure that what we have to that point is complies with the SRS requirements. So in other words, when we do the factory acceptance test, and interestingly enough now, in the 2003 edition of 1511, factory acceptance test was a highly recommended step. In the 2016 edition now, it's a mandatory step. We have to do it because that's when you bring the logic solver together with the application software, and then you'll do what we call black box testing, where you're stimulating inputs to stimulate or to simulate the SIF and looking for the outputs. And you don't see what's going on in the black box. So the FSA2 would be to make sure at that point that we have covered everything and that we've got what we need, and that the logic solver and the application meet the requirements. Because again, at this stage, you won't have all the field instruments. So there's certain things you won't be able to do. You can simulate with you can simulate the field equipment, of course, and you can check the timing of the logic solver through the application, and you can check that the application for each of the SIFs would achieve safe state. But without the field equipment, you won't be able to do the final timing. Now, there is no phase 4 of IEC 61511, so I'm not sure what you mean by that. There's only 3 phases. If you're talking about FSA4, FSA4 again is another requirement that was put into the 2016 edition, where we're supposed to do periodic assessments in the field to make sure that our performance is as per the design requirements. So again, I'm not sure what you mean by the phase 4 there. So the 1511 functional safety assessments are there to help us to make sure that we've covered everything we did. It's an independent cross-check of safety. That's basically what it is, but its primary purpose is to help us try and identify any potential systematic issues, to make sure that we've covered our bases and that we haven't introduced any problems. And that's why I say that's where the competency comes in, as well as making sure all the procedures are there and having the paperwork. Any other questions? Well, if you think of anything else, you can always email me. I'm always willing to answer any emails. Hopefully I addressed your questions okay. I'm sorry, I don't know what you meant by phase 4, because there isn't a phase 4. So if you're talking about operation and maintenance phase, then I'd be happy to answer questions on that. But again, from an engineering or integrator point of view, responsibility will finish when you hand over the final safety instrumented system to the end user. And that will be obviously part of the site acceptance tests and the final validation. Ooh, what's this? There's a big one here. Okay, what does this say? Phase 1 hazard and risk assessment, phase 2, and phase 3. Oh, you're talking about Yeah, I see what you're saying. But now when we talk about the life cycle, we talk about the 3 primary phases. You're referring to the clauses and how they've structured 1511. But the life cycle itself has 3 phases, which is the analysis, design and implementation, and operation and maintenance. Those are the 3 primary phases. And within that, of course, there are requirements and clauses. Okay, anything else? Yeah, I see what you're saying. So you're saying your phase 4 is design and engineering of the safety instrument system. Well, that's the design and implementation phase of the life cycle. And as I said, that would be where you receive the initial SRS and then you go through and do the detailed design from conceptual design. And here again, part of that, of course, will be the making sure when you do the FSA2 that the equipment justification was done correctly and that you are either using certified devices or you're using prior use justification. And the prior use justification I covered in a webinar a few weeks ago. So yes, that's correct. In that phase, you would be responsible for the hardware and the application development, design and development. That's why you need to have the functional safety management system in place and a functional safety management plan to define how you're going to manage functional safety through that particular phase of the life cycle. All righty then. Thank you, everyone. You've got my email address if you think of anything else. I appreciate you attending. I wish you all the best. Stay safe and look forward to seeing you on another webinar. Thanks a lot.